All right, welcome back to the channel. If you've been following along this series of videos, we've been talking about reading and writing data from uh, to and from files. So we've talked about CSV, JSON, JavaScript, a little bit about text. We wrote to a text file in our JavaScript example video. We've even touched on reading JavaScript data from inside and displaying it inside like an HTML. So we've gone over several videos. In this last video for this section, we'll just briefly talk about text files, and we'll show an example of logging. So with that, let's just jump in. And we're working in the same project. So if you haven't, if this is the first one that you've seen, then this is an example of what we're doing. And so what we're doing is we are using CSV. We're loading some beam data from a CSV file. We're going to load some patient and beam data. Again, this is just like dummy data from JSON files. And then in this next thing, what we're going to do, we're going to specify how many loops, how many iterations we want to go through. We want to loop through a structure set that contains 10 structures, and then add the structure information to a string. And we do it in two different ways. We do it using string addition and string builder. And so here, if we do it 50 times, we can just see that it takes 0.04 seconds to do it using string addition, but it only takes 0.02 seconds to do it using a string builder. And you might think, well, that's not that bad. If we do it again, and we do it like say for 500 times, or maybe like 1,000 times. And again, like if you're just using this for ESAPI, you're probably not going to need something that's that efficient. But if we just do it 500 times, you can see it took 1.2 seconds versus still only 0.25 seconds. So much faster, much more efficient to use string builder or concatenation. And the reason for that, just quickly or briefly, is that strings are immutable, meaning they can't be edited. So every time you air quotes add to a string, you are actually creating a new instance of the string. And so you have like duplicated strings in memory, basically, that are just a little bit different. And you do that for each iteration. So you can imagine like it just gets progressively longer and longer. And then what we did is the example that I gave with the JavaScript, we also actually logged a progress log to the text file. So all that did was just tell us, we can actually open one. Let's see. So if we look at like this one, we did 500, right? And what we did is for every structure, every time we looped through, and then for every structure, we calculated how much time it took to add the string. So when we start, it only takes 1.4 times 10 to the -5 seconds, and by the end, so that would be 4 zeros. By the end, we were at 3 zeros. And so when we did it to like 5,000 iterations, we were getting down to, we were starting at like times 10 to the -5 or 6, and we were getting down to as low as 0. To actually 1 zero, right? So to the -2nd. So that's just an example of what we've done so far. In this example, what we're going to do is we're actually going to log the progress of the script along with the total time. So we have two different logs. We've actually been logging every single time. So we have everything wrapped in a try-catch statement. And so if there's an exception, we say that we change this logged exception is true, and then that determines whether or not we do this. So if we hit this exception, we want to log it. And so what we're going to do, we actually have a stopwatch that gets stopped. So it gets started at the beginning up here. So we have a stopwatch that gets started. It gets created and started using the same method. And then we stop it at the end. But if you notice, like it's at the end of our try catch, or our try statement. So if we hit an exception, anywhere along the way we won't get to this. So that means that it's still running. So the first thing that we're going to do is we're going to, well, not the first thing, we're going to write the message in the stack trace to the user. But then we're also going to, after that, we're going to stop the timer. And then we're going to log what happened. So we're going to log that the application success was false. And then we're going to separate each of these things with a semicolon. You could also do like a new line. It doesn't really matter. However, whatever. The nice thing about text files is that they're super lightweight, right? And so they're useful for logging, etc. Especially if you don't care about like columns or whatever. And then the only thing about them, the only downside is that you have to have somewhat, or you can kind of figure it out by investigating the file, but you have to learn how the file is structured in order to really gain like whatever insights you want to from the file. So like you have to know, like for example, we know that we're splitting this information by a semicolon, right? So then if we read in a text file with read all lines, right, we get a bunch of lines, then we can loop through each line. If we know how it's structured, we can separate by the semicolon, and then we can get some different information, whatever. So that's really the only thing, is that you have to understand, or you have to know how the file is structured or formatted in order to like process it and like gain some insight from it. So let's see. So yeah, so we're just going to log some basic information. If we hit an exception, we're going to log that it's false. We're going to log the date time, when it was run, the total seconds, and then we're going to add a new line, and then say we're going to add like a flag that says begin exception detail, and then we're going to add another line with the message, the inner exception, and the target site. And then we're going to add another flag that says end exception detail, and then we're actually going to add 2 lines so that the next log is separated by a line, right? So let me just pause this for a second. I need to drink some water. All right, so and I guess we can go into this method a little bit. So if you've been following along, I've got a separate class or model for each of the different data type or file types. So CSV, JavaScript, JSON, Logger. So you might create like a Logger class. It really is super simple. So all we're going to do is we're going to pass in a message and a path, and it's just going to append whatever that message is to that path. So the first thing that it takes in is the path, and then it takes in the message. And we're going to append all the text so that we don't overwrite. We don't want to overwrite everything when we're logging, right? So we're just going to append. And then the nice thing about text files, one obviously is that because they're so like slick, they don't have slick meaning they don't have a lot of bells and whistles, right? So they're usually much smaller than like say like a Word document, right? Or something like that. Maybe not much smaller, but they're going to be a very stripped down file, right? No bells and whistles. So that's one of the nice things. The other nice thing is that like let's just run it, and so this will be a success, right? So let's just do it like 10 times, and we'll close it. And then just a side note, like, if you were doing this for like an actual program, maybe you want to know like the user, maybe you want to know the script that they were actually running, because maybe you use like a log for multiple scripts, or maybe you have a separate log file for each script. Maybe you're trying to like monitor when people are having issues. Maybe you want to know how many people are using it. And then we'll actually get into that here in just a minute, just like in discussion. But let's actually open up the log. So it writes to this log.txt file. And you can see I've been running it. I've run it a few times, and we had some failures. But then like down here, you see we have a bunch of successes. And this most recent time, right, is at 4:54. Total seconds it took was 6.8. And maybe you even want to include like the loop size, right? So you even have that log. But you could just assume like, okay, this probably took you know, this took less time than this, so they must have done it fewer times, right? But maybe you want to do that. So let's just hold this here, and I'll bring that up in just a second. But let's introduce an exception. So we're just gonna uncomment this, and all this is going to do is create an exception, and we're going to throw it at this line. So line 200. So now when we run it, we still have, just to show that we still have the document open. Let's pull that up. So we still have this document open, and we have this, right? And what's nice is you can run it. So let's do it 117 times. And so we hit an error. So it tells us what type of an exception. And then, so we can just close this. And you can see like it doesn't show up here. So that's kind of a bummer, right? But actually it's not, because we didn't also get another error that said file access not granted, or could not access file or whatever, right? So what happened was it wrote all of the information that we wanted to, but it did it while we still had the file open. So that's one of the nice things about text files, is that someone can have the file open, and as long as they don't save it really, like after you've already closed it and saved it, then you won't really lose any data. But hopefully people aren't really going through. Hopefully you're the only one that's going through your log files or whatever, or like people on your team. But so like we gave the message, there was no enter exception, and it told us like where we didn't give the line the line number. So what you would maybe want to actually do is include like the stack trace, right? I didn't do that here just because it includes like a bunch of lines and a bunch of different information. So I just gave some examples of some of the things that you could do. So the idea being that like maybe you have, let's say you are logging information for a bunch of different scripts, right? And so one of the ideas that you could come up with is that you could write another script that will parse all of your log files, and then it will look for errors. So if you know how you're documenting errors, right, then you can parse your log files, and you can pull out whatever information that you want, right? And then let's say you wanted to get fancy with it, and you wrote a script that would, like maybe with Python or something, that parses, or even C#, parses your text files, looks for the errors, pulls out the information that you want, like the user, the date time, which script it was, the stack trace information, the message, all that stuff. Pulled all that information out from your log file, saved it to a JavaScript file. Then you open up your browser, go to your HTML page that you've designed to as like a dashboard to view all of the exceptions that have happened. And maybe you have like filters like by date or something like that. So maybe you want to look the last week, what bugs did people encounter while they were using your scripts in your clinic, or whatever. This is kind of a silly idea, but it's not really that silly if you have like a lot of scripts and you're trying to like monitor or like maintain them. It can just help you. One of the things that I've learned is that when you're developing it, you're developing it for your use, right? And especially it's useful if you have like intimate knowledge of how it's going to be used. But let's say you don't really know yet how all the different scenarios in which it's going to be used. There's a lot of edge cases where they're going to run into issues where something just doesn't exist or whatever. So there's a lot of validation that needs to happen. So if you're developing your script and you're not validating everything up front, then, and even if you are valid, you're still going to find bugs. Like there's still going to be some sort of edge case out there where something didn't exist, or there were two things that existed or whatever, and you couldn't proactively think and solve all of those problems up front, right? So if you're logging everything, then, and you're monitoring those logs, then you can actually pull out. It will help you pull out information from when people are having issues. So like if you see that a particular user or whatever is having a particular issue, then you can actually go and investigate that without them even coming to you, right? And I think that's one of the useful things is when people encounter issues, there's usually two types of people. They either bug you about everything or they bug you about nothing. They literally just assume you're an idiot because it's not working, and they just don't have time to investigate further as to why they just stop using it, right? Or they bug you about everything, right? There's usually very few people who are in between, and that's fine. Like that's just how it is, right? Some people understand it, some people don't. Most people don't really understand the work that goes into writing scripts, so they don't really, or maybe they don't appreciate it, or they don't want to appreciate it. It doesn't really matter. Everybody has their own quirks and everything. So the point being, I'm kind of getting off onto a tangent, but the point being that if you are keeping logs and you can write scripts to automate the process of reviewing those logs, then you can actually pull out actionable information that will help you become a better developer. It'll help you fix problems that maybe you don't even know that exist, or maybe even that your users don't even know that exist, right? Like if you wrap a lot of things in try-catch statements, maybe the script doesn't even tell them that it failed, right? But maybe you need to know that it failed so that you can look into those situations, at more depth, right? So anyway, this is just an example of how you can do that. And so I hope that at least something in here has been useful. And yeah, so with that, I hope that, again, thank you for joining. And I hope that you have a great day. Happy coding.